So before we can start talking about how to solve a system of equations, because we're going to talk about 3 different ways today, okay? I really need you to know what a system of equations is. Have you ever heard of a system of equations before? Yes, because you did it in Algebra 1. This was something that you really focus on in Algebra 1 because it's a big deal in the Algebra 1 TEKS. Okay? So today is just a reminder, if that makes sense. Okay? So using context clues here, what is a system of equations? At least 2, right? First of all, it says 2, but this is plural. That means there has to be more than 1, right? Okay? So here's an example of a system of equations. How many variables are there here? 2. What are my 2 variables here? An x and a y, right? X and a y are my 2 variables. If I have 2 variables, how many equations do I need to solve that system? 2. Is it always that way? Like if I have 7 variables, how many equations do I need to solve the system? 7, right? For the record, we're not doing 7. The most we'll do is 4, for the record. But we really focus on 2, and we really, in Algebra 2, focus on 3. Okay, 3 variables. But that's some foreshadowing for tomorrow. Foreshadowing. Okay, today we're going to focus on 2. There's 3 ways we're going to solve a system of equations today. Graphing, substitution, and elimination. Okay, so let's start with graphing. Does it make sense that if I'm going to solve, well, let me ask it a different way. If I'm going to solve a system of equations by graphing, what am I looking for? First of all, what shape is this when I graph it? It's just a line, isn't it? What shape is this when I graph it? So really what we're talking about right now is a system of linear equations. But you already know that because you wrote it down, right? In our objectives for today. If I graph 2 lines, what am I looking for? If I graph 2 lines, where they intersect, where they cross. That's what I'm looking for, right? Okay, so let's see, which one do I want to do? How about 4? Can we do number 4? Let's do number 4. I don't want to do number 1 because it's too easy, right? People always tell me, you always do the hard ones for homework and you do the easy ones for notes. And I'm like, liar, liar, pants on fire. I do not do that. Okay? So here's the proof right here. This is the 4th one out of 4 problems. Does it make sense? This would be the most difficult. Yeah? Okay. So, what do you think I have to do in order to start working on this system? I got to get the y by itself, don't I? I got to get it y equals mx plus b so I know what my slope is and I know what my y-intercept is in order to graph it, don't I? Okay? So if we're dealing with the first equation here, let's get this down just a little bit to give us some room to work. I have 4x plus y equals 2. So what do I need to do first? So subtract 4x from both sides. So y equals negative 4x plus 2. Is that good? Now I know this is asking you to remember a long time ago, but remember 2 years ago when you were graphing these by hand? Or like a couple weeks ago when we talked about it? What do we have to graph first? First of all, what do we know? I know the slope and I know the y-intercept, right? What do I have to graph first? The 2, right? The 2 is the what? The what? The y-intercept. So along the y-axis, I have to go to 2 and put a dot. From that dot, where do I go? So remember, I need a fraction for my slope. So I put it over 1 and I go down 4. If I go down 4, 1, 2, 3, 4, now which direction do I go? Because I got to go over 1, right? Do I go over left or over right? I have to go the positive direction because I already took care of the negative 4 here, don't I? Can I go down 4 more? I mean, kind of, right? It's a little bit off the graph, but we're smart enough to see one above or one below, right? So from my y-intercept, could I go up 4? As long as I go left 1, correct? Now what? Oh, draw the line. Okay. Well, here's the deal. Since I drew 4 points, the line's a whole lot easier to see than if I would have just drawn the 2, right? Okay. So just for the record, when I graph these, I'm always going to graph all the points I can see because it makes it easier to actually see the line. Okay. Any questions about that one? So that one's done now. We can't do anything else, right? Okay, so let's go to the second equation. I have x minus y equals 3. So what do I need to do with this equation? So if I subtract x from both sides, I get negative y equals negative x plus 3. Is y by itself? No, it's not, is it? What do I have to do? I'm going to divide everything by negative 1. Okay? Now, I purposely did this, literally dividing everything by negative 1. Could I have just drawn one line over here, divided this whole side by negative 1? Yes, but when I graded your tests last week, that was something that some of you messed up on. You divided the whole side by negative 1, but forgot to divide this one by negative 1. So I purposely did this today to help us because I know that's a problem for some of us. Okay? So x minus 3, that's going to help me remember to divide that second term by negative 1. Okay? I didn't mean that judgefully, so I hope that didn't come out judgefully. That is not even a word. Judgmentally. Thank you. Judgefully? That's definitely not a word. Okay. So now is my y by itself? Yes, so how do I go about graphing this line? Start with the negative 3, so on the y-axis I go down 3. And then what's my slope? So 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Again, how many points does it take to make a line? Only 2. How many did I draw? All that I could see, right? Because that makes it easier to draw the line. Okay. Am I finished? What was I looking for? The point of intersection, right? Just doing this, all that proves is that I know how to plot points and draw lines, right? But the directions actually say solve each system. So far, all I've done is graph each system, right? In order to solve each system, I have to find the point of intersection. What is that point? 1, negative 2. Now that is the solution. Yes, sir. It's the intersection of the two lines that I'm looking for. I'm not looking for the y-intercepts. I'm looking for where these two lines cross. Does that make sense? Are you lying? Okay, good. Any questions? While we're here, would you please go ahead and circle 2 and 3? We just circled 2 and 3. Okay? Now, people were questioning this. Remember, if it's only got one variable, it's telling you which axis the line is crossing and where. So if this is crossing the x-axis at negative 3, isn't it going right there? Does that make sense? Okay, don't try to make that too hard. Let's talk about substitution. What happens when I'm not here? We have a substitute, right? So I'm gone and someone else comes in. So does it make sense that if we're solving a system by substitution, I'm taking something out and putting something else in? Okay, so look at number 7. Okay. What does it tell me right off the bat? It tells me what y is. What do you think I'm going to do with that y? I'm going to substitute it in for y in the other equation. So I'm going to say 5x plus 4 times negative 5 equals negative 20. Once you're done with substitution, how many variables should you have left? only one, right? Because that's the whole purpose of substitution, is to get rid of one of the variables by substituting in what I know what it means. Okay? So I have 5x minus 20 equals negative 20. Whoa. Sorry. What now? Oh, okay. Add 20. 5x equals 0. Divide both sides. Whoa. Divide both sides by 5. X equals what? 0. So I'm not solving this by graphing. I'm solving it by substitution. But where is the solution? It is still the point of intersection if I graphed it. So I can't leave my answer like this. I don't even want to go over here and write x equals 0, y equals negative 5. How do I want to write my answer? As a point. That's exactly right. What is my answer? 0, negative 5. Now, is that correct? Are you positive? Could you be positive? How? We could check it. Okay, negative 5 equals negative 5. Okay, perfect. So now it's good because we checked one. Oh, it has to work for both. Okay, 5 times 0 is 0. 4 times negative 5, negative 20 equals negative 20. Then I am positive that is the right answer. Got it? Can we look at number 8 as well? Number 8 is a little different, isn't it? It doesn't tell me a variable, or it doesn't define a variable for me already in the beginning, right? So what I have to do is now I have to choose a variable to solve for. Because one was already solved for me before. I have to choose one to solve for. Which one of these would you choose to solve for? I want to try to solve for one that's by itself, right? I would probably choose this x. I probably wouldn't choose this y. First of all, it's not by itself. And I'd eventually have to divide everything by 7, which would give me a fraction right here, right? This one might be okay if I didn't have any other choice. Because if I divide everything by 2, everything in the second equation is divisible by 2, right? So that wouldn't give me any fractions. I probably wouldn't choose this y. Because eventually I'm going to have to divide by 8, and that would give me a fraction here and a fraction here, right? So it's a matter of choosing the best variable to solve for. Do you understand why this x is the best variable to solve for? Okay, so if I'm going to subtract 7y from both sides, that gives me x equals negative 7y. Where do I put that? So right here? Oh, so I can't use the same equation to substitute it in that I used to solve for it? Correct. Okay, if I use the first equation to solve for the variable, I have to substitute it into the other equation. Okay, because if I substitute this in right here, it's just going to give me a true statement. It's not going to help me solve anything, is it? Okay, so I'm going to go right here, right? Does that make sense? What do I know that x equals? Negative 7y. So 2 times negative 7y minus 8y equals 22. Now what I said when I did number 7 was, as soon as I do the substitution, I should only have one variable left. Do I? Yes, I only have a y left. Now there's 2 of them, but it's still only one variable. Does that make sense? I can combine those like terms after I do some simplification first, can't I? Okay, so what's 2 times negative 7y? So negative 14y minus 8y equals 22. What is negative 14y minus 8y? So negative 22y equals 22. If I divide both sides by negative 2, or excuse me, negative 22, what does y equal? Negative 1. Yay, we're done. Oh, no, we're not. That's okay though. It's not that hard, is it? If I have y, which one do I need to solve for now? I need to solve for x. But guys, look, we already solved for x. When I go to substitute this back in, does it make sense that I should go right there? X equals -7 times -1. What does x equal? 7. What is my answer? 7, -1. So the hardest thing you're going to have to figure out is which one goes first and which one goes second. Right? Once you get there, and that's not hard, is it? I was just being silly. Okay? But we do need to check it, don't we? 7 plus -7. Is that 0? Okay. Let's see. 2 times 7, that's 14. -8 and -1, that's 8. So it's 14 and 8. Is it right? Then I'm confident that that's the right answer. Okay. While you're here, will you please circle number 5? And would you also please circle number 11? Whoa, there we go, number 11. Got it? Okay. Now we have one more way that we need to solve systems of equations, and that's by elimination. Okay? Now, making sure you remember how to solve by elimination, you are basically becoming variable assassins. This is legal because variables are not people. Assassinating people is illegal. Okay? So just make sure you understand we are variable assassins, not just assassins. Okay. So let's look at 15. What I'm eventually going to do is combine both equations together. And when I combine both of the equations together, I need to eliminate a variable. That means one of the variables needs to have the same number but opposite signs. So basically the opposite numbers. Okay? Are the x's opposite numbers? Well, they're opposite signs, but they're different numbers, right? Are the y's opposite numbers? Again, opposite sides, but not opposite numbers, right? So I have to do something to make one of these variables eliminate. So I'm going to choose to either multiply or divide. Typically, it will be multiplication. Very rarely will it be dividing, but it could be. Okay? I'm going to choose to multiply one of the equations or the other by some number that I just decide on, I just choose to make one of the variables eliminate. So if I multiply the top one by 2, what would that do for me? That would give me a 16x and a negative 16x. Would those eliminate if I added them together? Yes. So can you tell me my other option? So you just told me what to do if I was going to eliminate the x's, right? How would I eliminate the y's? Well, remember they would need to be the same number. What number is it easy to get both of these numbers to become? 42, right? What would I have to multiply this top one by? 7 and the bottom? 6. So do you want to mess with multiplying the top by 7 and the bottom by 6? Or do you want to try to multiply the top by 2 to eliminate the x's? That seems a lot easier, doesn't it? So is it okay with everyone if I do that? The point that I'm trying to make is that there is more than one way to do this problem. Does everybody understand that? Okay, so we're choosing to eliminate the x's by multiplying the top equation by 2. So I'm going to write that right over here. Okay, I get 16x minus 12y equals negative 40. Is that what you get? Okay. Now, if it's okay with you, I'm just going to rewrite this second equation. I'm not doing anything to it. I'm just rewriting it so it's underneath the first equation. Now, what do I want to do with these two equations now? Yeah, I want to combine them, right? Sometimes people say add them. Sometimes I think that gets confusing because really all we're doing right now is combining our like terms of the two equations. Are you okay with that? Okay, so if I combine 16x and negative 16x, what do I get? 0. If I combine negative 12y and 7y, what do I get? Negative 5y. If I combine negative 40 and positive 30, negative 10. Oh, wow. Yeah, exactly. All I have left to do is divide both sides by negative 5, right? So y equals 2. I'm done! Ugh. Because we're still trying to solve a system, right? If I'm trying to solve a system, where is the solution? The point of intersection. So I can't just have y equals 2. It has to look like a point. It has to look like an ordered pair. So if I know y, what do I need? X. So I'm going to have to substitute y into one of these equations here to find x. Which equation would you choose? I really kind of have 4 to choose from, right? Most of the time I'm going to want to go back to one of the original equations. Most of the time. Okay? Like 95% of the time. Or 98% of the time. Which one of these two would you choose? Why would you choose the top one? Smaller numbers. Yeah, that's exactly right. We want to choose the easier one. Okay? That doesn't make us lazy. That makes us mathematicians. We're using our brain to choose a better choice. Okay? So I say 8x minus 6 times 2 equals negative 20. So 8x minus 12 equals negative 20. So what do? If I add 12 to both sides, I get 8x equals negative 8. Dividing both sides by 8 gives me x equals negative 1. Okay, 8 times negative 1 is negative 8. 6 times 2 is 12. Negative 8 minus 12 equals negative 20. Correct. Okay. Negative 16 times negative 1, that's 16. 7 and 2 is 14. So 16 plus 14 equals 30. Then I'm absolutely positive this is right. So all I have left to do is write it as a point. That's exactly right. So what's my answer? Negative 1, 2. Questions? We good? Okay. Please look at 19. Because 19 is a mess. Why is 19 a mess? Yeah, it's all messed up. Okay? In order for us to do elimination, look how the one we just did was. The x's came first, and then the y's, and then the equal signs, and then the constants. I need it in that order. I don't want just like terms lined up. I need it in this order. X, Y, equal, constant. Okay? And that may not make perfect sense to you today or even in the next couple days, but if you'll give me a couple days after that, trust me, I promise it will make sense. Can you give me a couple days if it doesn't make perfect sense right now? Okay, so x's, y's, equals, and constants. Okay, so on 19, what do I need to do first? Yeah, look, these are on the same side of the equal sign. Am I allowed to just do this? Have I changed the value of the equation? No, I just switched the order, right? Now I got to make sure to keep the right signs with the right signs. If this was a positive 11, I would need to make sure this stays a positive 11, right? Okay. What about here? Yeah, see, it's not as big as a mess as it originally looked like, right? Because can't I just write negative 10x minus 10y equals 20? And now isn't it in the right order? So what we have to do now is decide what to eliminate. Okay? Which variable do you think I should try to eliminate? Which one do you think would be easier? The y. What would I have to get x to eliminate it? 110, right? What would I have to get y to eliminate it? 40. Which one's easier? Oh, can I argue with you for a second? Is that okay? I could get it to 40. What else could I get it to? Oh, 20. Can't I get it to 20? Wouldn't that make it easier? Right? Because then I only had to multiply the top by 5 and the bottom by 2. Now we'll argue about that in a second, but for now we're okay, right? If we can get them both to 20, can't we? Okay, so what you said was we should multiply the top by 5 and the bottom by 2. And I don't agree with you exactly. Here's why I don't agree with you exactly. Because if I multiply the top by 5, that gets this to be negative 20. And if I multiply the bottom by 2, that one gets this one to be negative 20. And they have to both be what? Opposites, right? One has to be positive 20, one has to be negative 20. So which one do you choose to be a positive? And which one do you choose to be negative? More importantly, does it matter? No, it does not. Okay, so are we going to multiply by negative 5 or are we going to multiply by negative 2? Negative 5, okay. Again, does it matter? No, it does not. Why did I choose negative 5? Because she said negative 5. That's why I chose negative 5. Okay, because we could have just as easily chosen negative 2. Does everybody understand that? Okay, so if I multiply this one by negative 5, is it okay if I write it over here? So I'm going to get positive 55x plus 20y equals 180. Can you do that in your head? I just did. What is 30 times 5? 150. What's 6 times 5? 30. What's 150 and 30? 180. It's negative 180, right? Because we've got a negative 5 times a positive 36. Okay. So now if we multiply the second equation by 2, is it okay if I write it right down here below? Okay, so 2 times negative 10, that would be negative 20x minus 20y equals 40. Now, if I combine these two equations, won't the y eliminate? Perfect. So I have 55x minus 20x. So negative 35, oh, excuse me, positive 35x, right? Positive 35x equals what? Negative 140. Excellent. So to solve for x, what do I need to do? Divide by 35. X equals negative 4. Now that I have one variable solved for, what do I want to do with it? Where do I want to plug it back in? Probably one of these first two original equations. Why do you want to choose the second equation? So, does it matter? No. So we're choosing the second equation because that's what she said, right? Okay. So I say 20 equals negative 10 times negative 4 minus 10y. So I have 20 equals 40 minus 10y. If I subtract 40 from both sides, that gives me negative 20 equals negative 10y. And if I divide both sides by negative 10y, y equals 2. So what did we get as our solution? Negative 4, 2. Is it correct? Negative 4 times negative 4 is 16. 16 and minus 22. Hold on. Oh, I put it in the wrong place, didn't I? The y is 2. The x is the negative 4. So negative 4 times 2 is negative 8. 11 times negative 4. Negative 11 times negative 4 is positive 44. So negative 8 and positive 44 is 36. Yes? No. So first one works, right? So I have 20 equals negative 10x times, negative 10 times negative 4, which is 40. And then I have negative 10 times 2, which is, so 40 minus 20 is 20. Oh, perfect. Okay. So what I just showed you was an example of having to be careful, right? Because I accidentally did that. I wasn't paying very close attention, was I? I didn't do that on purpose. It was an accident when I substituted in the wrong place. So we just have to be careful. Is that fair? I mean, that was a perfect example. Like I said, I didn't mean to do that. It just happened. We just have to be careful. Okay? Now, can I show you something real quick? Here's my notes from last period when I did this example for last period. Notice we multiplied by 5 and negative 2. So we did different signs right here, right? We still got x is negative 4. And then we substituted into the first equation, and we still got y equals 2. We still got negative 4, 2 is our answer. So a second ago I was asking you, does it matter? Well, not as long as we do it correctly, right? It doesn't matter, and here's an example of that. Okay? Do you have any questions about elimination, substitution, or graphing? Okay? While we're here, would you please circle number 16? Would you please circle 23 and 25? Okay? 1, 2, 3, 4, 5, 6, 7. Do you have 7 circled? 2, 3, 5, 11, 16, 23, and 25. Yes? Okay.